Hi everyone, I hope you're having a great Tuesday. Today we're going to talk about how we can graph if we're giving an equation in standard form. So we've done some graphing before where we're given vertex form, but we haven't done anything with standard form yet. And there's actually, some people might think you have to go all the way and convert to standard form because that's what we did yesterday to be able to graph these things, but it's actually not that hard. So remember, standard form is ax squared plus bx plus c. So if we're given an equation that looks like that, the question today is, how can we graph it? How can we graph that equation? So we're going to start with just a couple of warm-up problems from yesterday. So going from standard form to vertex form. So remember, to do this, we have to label out A, B, and C, and then there's a special formula we use to be able to find that x-coordinate. So if you want to try this problem on your own, you can go ahead and pause the video now and go ahead and try it on your own. So if you're coming back to us or you decided to wait and do it with me, let's give it a shot. So we're going to label out A, B, and C. So remember, we're looking at ax squared plus bx plus c. So the a is whatever's in front of the x squared. So in this case, that's going to be a negative 4. And be really careful here. You don't want to do negative 4x squared. This is a no x zone, right? We talked about the no x zone. So we shouldn't have any x's in any of these. Just looking for the numbers in front of each term. So the b value here is going to be 8. And our c value right here is negative 6. So we have our A, B, and our C. And some of you might be thinking, hey, that C, we haven't used it really much, and today we're going to use it a little bit. So don't discount that C just yet, because they're all important. So remember now, what we want to do is find the x-coordinate of the vertex. So the x-coordinate of the vertex, remember, is always negative b over 2a. So negative b over 2a, we're going to use our values over here to find that. So in this case, that's going to be negative 8 divided by 2a, which is 2 times negative 4. Well, 2 times negative 4 is negative 8, so it's just negative 8 over negative 8, which is just 1, right? Because the negatives cancel to a positive, and 8 over 8 is just 1. So we're going to take that 1. That's our x-coordinate of the vertex. We have to find the y-coordinate of the vertex, though. So our vertex right now, what we know is that the x-coordinate is positive 1. And I have to plug that in to find my y-coordinate. So my y is going to be negative 4 times 1 squared plus 8 times 1 minus 6. So negative 4 times 1 squared, that's just negative 4, plus 8 minus 6. Well, negative 4 plus 8 is positive 4. Minus 6 gives us, negative 2. So our y-coordinate here is negative 2. So now I have my vertex. So when I have my vertex, I can go right to vertex form. So it's negative 2 for the y, so then in the equation it's going to be y plus 2. And in the vertex right here, we have a positive 1, so it's going to be x minus 1 squared in our equation. Now remember, to find that coefficient in front of the parentheses, we just have to look at a. So right here, I'm going to steal that a and put it right in front, negative 4. So that's going to be a parabola that has its vertex at 1, negative 2, and it's going to open down because we see that negative 4. Alright, let's take a look at another example. There's one more example just like yesterday, so if you want to try this one as well, you can pause the video just for a second and take a look at it. Alright, welcome back if you tried it. If you didn't, if you want to take a look at it with me, let's take a look. So we're going to label out A, B, and C. Our a value here is just whatever's in front of the x squared. So that's going to be 2. Our b value over here is negative 12. And our c value is 15. Standard form, written in descending order of powers of x, just taking those coefficients. So now my x-coordinate, remember the formula for my x-coordinate of the vertex is always going to be the same. It's just negative b over 2a. So in this case, that's going to be negative 12 divided by 2a, which is going to be 2 times 2. So that gives us positive 12 divided by 4, which is 3. So that's the x-coordinate of my vertex. So I'm looking at the vertex. My x-coordinate is going to be 3. Oops, sorry, not x, 3. So we're going to have 3 there. And then to find the y-coordinate, I have to actually plug in 3, because I know this is the equation for y. So I'm going to plug in the 3 and see what I get for y. So y is going to be 2 times 3 squared minus 12 times 3 plus 15. 2 times 3 squared, that's 2 times 9, which is 18. Minus 3 times 12 is 36, right? 36 inches and 3 feet, plus 15. So 18 minus 36 is negative 18. Plus 15 is going to give me negative 3. So that's my y-coordinate of the vertex. So I have my vertex now. It's 3, negative 3. Covered up my parenthesis there. So I can put it into vertex form. It's going to be, if it's negative 3 for the y in the vertex, then it's going to be y plus 3. We've done a lot of these problems now. Equal to x minus 3 squared. And then that a value, whatever's in front of the parentheses, is just going to be my a value right here. So it's just 2. And I have my vertex form. So I started with standard form and able to get to vertex form. So that's what we did yesterday. Now let's take a look at something new. So can we get a graph from standard form? So we've talked a lot about being able to go from vertex form to a graph, but we haven't talked about how wide the parabola should be. Everyone keeps asking me, how wide should that graph be? They say, does it really matter? So up till now, we haven't really taken a look at that. But now we're going to talk about, how wide should the graph really be? And going from standard form actually is a little bit easier. So this is the first problem we did for the warm-up. And we found out that the vertex was at 1, negative 2. We found out the vertex was at 1, negative 2. So if I'm going to think about a graph of this guy, the vertex was at 1 and then negative 2. So there's our vertex. And then if you remember from our bell work, we actually found out that this opens down because we have a negative a value, so it's going to be a frowny face parabola. But I don't know exactly how wide to make it. Well, there's a pretty easy way to do it. What we're going to do is we want to find the y-intercept. We want to find the y-intercept. So, thinking about the y-intercept, if we think about just in general, any graph, so we're going to come back to this one in a second, but if we just think about any graph, we know that if I'm going to change my color here, because it'll just make it a little more obvious. So we know if we're at any point on the y-axis, any y-intercept, for any one of these, my x-coordinate is going to be 0. So 0 something. No matter where I am on the y-axis, my x-coordinate is 0. So some of you might already see where I'm going with this. If I want to find out what my y-coordinate is when x is 0, I'm just going to plug in 0 for x. So both of these x's I'm going to plug in 0, and it's going to give me my y-intercept. So you can see now what I was talking about with the c being important here. When I plug in 0 for x, y is going to be negative 4 times 0 squared plus 8 times 0 minus 6. Well, both of these zeros just cancel out those terms. It just cancels out those terms. So my y-intercept is just negative 6. So whatever that c value is, it's my y-intercept. So I go down 1, 2, 3, 4, 5, 6. There's my y-intercept. Now I have the vertex. I also have the y-intercept. And so I can graph a nice picture of that parabola. Well, you could probably graph a better picture than I did. That wasn't very good. But I can see how wide that parabola should be. So if I know the vertex, that's my first piece. And then my second piece is just looking at that c value, and that's going to give me how wide my parabola should be. So let's take a look at another one. Alright, this is the other one that we did for a warm-up problem. We have our equation here in standard form. So if you remember, we were able to put that into vertex form by finding the vertex first. So we found the vertex. We found that it was at 3, negative 3. So if I want to graph this, I'm going to start by just plotting that vertex. So at 3, negative 3. So let's see here. 1, 2, 3. And then we have negative 1, 2, and 3. So that's that point right there. So we have our vertex. And if you remember from our vertex form, and also just by looking at the A here, we know that it's going to open upwards, but I don't know how wide it's going to be. So based on the last example we just did, we know to find the y-intercept. So to find where that point is going to be along the y-axis here, I can just look at the c value. So remember here our A, B, and C. A is 2. B is negative 12, and our C here is 15. So all I have to do is look at that 15, and that gives me my y-intercept. So we got to go pretty high up for that. So let's see, 1, 2, 3, 4, 5, 6, 7, I need more room. 8, 9, 10, 11, 12, 13, 14, 15. So 15 right there is my y-intercept. So now this is going to be a terrible drawing, I think. But it's going to come down like this, and then our vertex has to be down here, and then it's going to go back up. So that's a pretty skinny parabola. And again, the only thing that tells me that is just based on where that y-intercept is. So I plot my vertex, which we'll talk about in the next slide again, how to get that. Remember that x-coordinate is negative b over 2a, and the y-coordinate, we just plug it in. So we found the vertex in the warm-up. You can go back and look at that if you want to. And then to find the y-intercept, I just look at the c value. Because when I plug in 0 for x somewhere on the axis here, this x is 0, which cancels out that term. This x is 0, which cancels out the second term. All I'm left with is that 15. So let's try starting one from scratch. And what we're going to get right now is a procedure for doing this. So to graph in standard form, I'm going to write this down if you haven't written it down yet. So to graph in standard form, first thing we have to do is we have to find the vertex. So we have to find the vertex. Remember, the vertex has an x and a y coordinate. So the x coordinate, remember, it's just negative b over 2a. And then to find the y coordinate, I'm going to plug in that x coordinate. So plug in the x coordinate, which we found from above. So it's just negative b over 2. Then I'm going to plug that in for x, everywhere I see an x. Then I'll have my vertex, so I'll have the xy for my vertex. Then the second thing I'm going to do is I'm going to plot the y-intercept. And the y-intercept, remember, is just c. It's just the c value. It's whatever the constant term is there. So just that constant term at the end is going to be my y-intercept. So let's see if we can graph this. So the first thing I'm going to do is find the vertex. So if you want to pause the video right now and try it on your own to find the vertex, plot the y-intercept, that might be a good idea. I'm going to make that c a little bit better. Alright, so if you paused the video and tried it, you can check your work with me now. And let's take a look. So we're going to write out a, b, and c. My a value here is 1 because there's nothing in front of the x. My b value is negative 8, and my c value is 9. So my x-coordinate of my vertex, so the x-coordinate, remember, is negative b over 2a. Negative b is negative 8, so those are going to cancel out to a positive. Divided by 2a, that's just 2 times 1, so that's just 2. So those two negatives cancel to a positive, so I have 8 over 2, which is just 4. So I know the x-coordinate of my vertex is 4. Then to find the y, remember we just plug in the x. So to find that y, it's going to be 4 squared. I'm just plugging in the x-coordinate here. And then it'll be minus 8 times 4 plus 9. Well, 4 squared is 16. 8 times 4 is 32, plus 9. So that gives me negative 16 plus 9, which is negative 7. So my y-coordinate is negative 7. So now I have my vertex. Let's plot that and do it over here. So negative 7, sorry, 4, negative 7. 1, 2, 3, 4. Negative 1, 2, 3, 4, 5, 6, 7. Pretty low there. All right, so there's our 4, negative 7. And then it's going to open up, thank goodness, because I don't have any room to go down. That we can tell just from the a value there. We have a positive a value, so it's going to open up. And then my y-coordinate, my y-intercept, is just the c value. So I just look right here at the c value. It's just 9. So we go up 1, 2, 3. Might run out of space here. 4, 5, 6, 7, 8, 9. So, well, that's right there. Sorry about that. And I'm just going to plot our parabola here. Another pretty skinny one. A little bit wider than the last one, but it's still pretty skinny. Alright, I do want to try one more example here, but I'm about to run out of time on my video. So what I'm going to ask you to do is go back to the Moodle page, and there is going to be one more video on there. You are going to want to watch this because I'm going to do this one, and I'm also going to go over a list of all the things that are going to be on the quiz on Friday. So the next 2 days are going to be review, and then our quiz is going to be on Friday. So do take a look at the second video for today, and there's also a crypto quip for you guys at the end. So go ahead and take a look at the second Moodle video, and I will see you in just a few seconds.